Natural gas is emerging as a major motor vehicle fuel. It's clean burning, cost-effective, and the supply is abundant, especially in North America. And there is a new aluminum composite reinforced cylinder that is lightweight. Another criteria by which these new cylinders are judged is performance under gunfire. How do they hold up under gunfire? And when they're pierced, how do they behave? The answer to the first question is that they are very difficult to pierce, as these first tests demonstrate. The bullets here are standard police issue loads, and each projectile will have a penetration of approximately 50% of the composite thickness, or less than 1/8 of an inch. The distance from the firearm to the cylinder was approximately 25 feet. There was no severe damage to the cylinder, other than damage to the composite matrix. There was no penetration of the metal. And even after this test, the cylinder performed well within its design limits. The cylinder exceeded the minimum burst pressure of 7,500 psi. All cylinders were charged with natural gas. What is happening is the target and the bullet are basically exploding, but there is very, very little damage to the composite. A portion of the composite on the right-hand side of the screen can be seen to flip out and pull back in. However, the depth of the damage to the composite was again less than 1/8 of an inch. The total thickness of the composite and the cylinder wall is over 3/4 of an inch. The weapon used here, the AR-15, is a standard military assault rifle used by both the U.S. and NATO countries. The test involves a direct hit with armor-piercing projectile. The vent down was completely safe. There was no ignition of the natural gas, and it vented down in less than a minute. You may safely conclude from a review of these tests that even under the most severe conditions of high-speed collision, bonfire, dynamite, and gunfire, these new CNG cylinders performed safely and predictably. The service pressure of the cylinders, 3,000 psi, was maintained under extreme abuse. There was no venting of the gas in most cases. The exceptions were the direct penetration gunfire tests, which were of course designed to penetrate the cylinders, while the bonfire tests were designed to specifically check safety valve performance. In all these tests, there is no fragmentation of the cylinders because the composite matrix completely encapsulates the metal shell of the cylinder itself. To the best of our knowledge, there has never been any cylinder ever built which has been subjected to the kinds of tests you've just seen. And once again, the basic reasons for these tests were to establish the total integrity and strength of these CNG fuel cylinders under the worst conditions, as well as the overall safety of natural gas as a vehicular fuel.